watching from. My name is Mo Friday. I'm going to continue where I stopped last time, and we're going to be dealing with properties of real numbers here. So we are going to be taking few properties of real numbers, and I believe you will definitely get value for this time out. So let's stay tuned as I take us through this process. Okay, and the first properties we'll be looking at is cumulative properties of addition. The example below easily illustrate what that means. That is to say that a plus b is equal to what? B plus a. So that is what it means when we say cumulative property. So what that simply implies is you can as well say 2 plus 3 is the same thing as 3 plus 2. Right? So that is what it means. So we also have cumulative properties of multiplication, which is also a times b. A times b is the same as b times a. We can quickly take an example on that to demonstrate or to illustrate what that means. So that is to say 2 times 3 is the same thing as 3 times 2. This gives you 5 and this gives you 6. So simply what it is. So there are other properties of real numbers we'll be discussing in this short tutorial video. So the next one we'll be discussing here will be associative properties. Very important. So let's quickly look at the associative properties. How we also have the associative properties in addition and in multiplication. So let's quickly look at that. Associative properties. Okay, let's look at it of addition. Alright, so let's quickly look at this. Example of this will simply be a plus b plus c, same thing as a plus b plus c. And let's look at the associative properties. Please pardon my writing, of multiplication, right? So that will give you very simple, will give you a b c equals to what? A b c. Now how does this work? So this is there are several ways you can apply this. Okay, this is also used when you talk about opening a bracket and all of that. So what this means is, so we are still going to take example by making our a become the 2 and our b equal to 3. So we are going to plug in these figures in the alphabet, so to prove to you that the associative property is true for addition and for multiplication. So let's quickly run that out here. So taking this example down here, okay, this will be a is 2, so that would be 2 plus 3. So also c, let's see b 1. Let me use, let's see b 4. So it can be any value anyway, you should get the same answer. So plus 4 equals a is 2, b is 3, and c is 4. So if you add your left hand side and your right hand side, you should get the same answer, to prove that the associative properties for addition and multiplication are actually true and they're the same. So this will become 2 plus 7 equals to 7 plus 4. So 2 plus 7 will give you 9, and 7 plus 4, sorry, this is 5, 3 plus 5, so 2 plus 3 is 5. Alright, pardon me. So this will give you 7, 9, this will give you 9. So this shows that it is true. The associative properties for addition is true for addition. So we are going to work this out for multiplication. So let me take this out. Alright, so let's take this out. So let's quickly work on this for multiplication using the same parameters that we use. Taking a to be 2, b to be 3, and c to be what? 4. So we come down to a is 2, b is what do we have there for b? B is 3 times c is 4 equal to bracket a is 2, b is 3, and c is 4. Take note there's a multiplication here just for those that may not know watching this video, because yeah, so this video should cater for everyone at any level of mathematics. So this becomes and take note, and also is following the rule of both maths is better, is advisable, and for you to always deal with the value in your bracket so that we can multiply others. So this is 2 times 3 times 4 is 12, right, equal to 3 times 2 is 6 times 4. So 2 times 12 is 24, and 6 times 4 is 24. So this goes to show you that associative properties of multiplication is true for both addition and for multiplication too. So the next properties we'll be discussing here, there are other properties. They are the additive property. It's very important that the identity property is very important. It's very useful. So as you go further in math, for these two properties here, anybody from the junior class can apply this knowledge. But as you go further, the identity will apply to people in the senior class, and also for people that are actually taking further mathematics. So the other one here I'm going to discuss is the additive what? Identity. Okay, identity properties. Okay, I'm going to give example here on how this works. So this simply says that a plus 0 equal to 0 plus a equals to what? 0. Yes. So it is true. Sorry about that. That should equals to a or 0. Yeah. So it is true for addition. So you have but it is not true for multiplication, because if you multiply this, you will definitely get 0 as your answer. So if you say a plus 0, obviously it's a. 0 plus a, obviously is a. But for multiplication, this will not be true for multiplication, because if I say a times 0 is not equals to 0 times a, this will give me it will yeah, of course it's equal, rather, pardon me, or this thing just fly through my ball. What I'm trying to say next is it is not the same. The additive identity properties does not apply to multiplication, because you will not have the same answer. So this need not be here, so because it does not apply to the identity properties, that's multiplication. So let's go back to the additive inverse. Very important concept here. Inverse property. Very important concept here. Okay, so what does that say? That gives us now. Okay, I'll explain further. So let's take a simple example. A plus a equals to what? A plus minus a will give you what? 0. Now how does this work? And I believe you will understand that if a number is not carrying a positive sign, it means if a number is not carrying a positive sign, it means that number is carrying a negative sign. Say for instance, we want to add two. I'm not going to bring this in anyway. So we want to add two numbers. Let's say we want to add two. We want to subtract two numbers. So every number has a positive sign attached to it, to the number, right? So it is only when the number is no longer positive that a negative sign is indicated to show that it is not a positive number. So therefore, how do we add? It always appear in this form. It will be -2 -2. So because that is the application of this additive inverse. So because negative, there's a rule. If you don't know, let's just put it up here. Plus times plus is plus, minus times minus is plus, plus times minus is minus, minus, and minus times plus is minus. So because minus times minus will definitely give you plus, so that is why when you now say 1 plus 2 is equal to 4, but the actual presentation of this 2 plus 2 is actually 2 minus into bracket minus 2. So just to bring that in, so to explain the additive inverse, so additive inverse simply is true for minus a plus a is equal to a plus minus a. So what does that mean? So the same way I try to illustrate this, so I said our a is what, let's a is 2 for instance. So for the additive identity properties, you have 2 plus 0 equal to what, 0 plus 2. It still gives you what, 2. So it is true on that note. So let's go to the additive inverse. So when a is 2, we said minus a plus a is equal to what, a plus into bracket minus a is equal to 0. So let's prove that with a what, with a figure, just to clarify that. So we say minus 2, taking this from here, so minus 2 plus 2 equals to 2 plus minus 2 equals 0, right? So this becomes minus plus 2 obviously is 0. 2 plus minus 2, this becomes 2 minus 2, right? That gives you 0. So it is true that the additive inverse property is true and probably presented. The last but not the least I'll be discussing, there are several of them here. The last of not the least I'll be discussing here, might not give an example, but let's see if I can take this off the chart. But let me just leave that here. The next one is going to be multiplicative identity properties. So multiplicative identity property. Okay, multiplicative identity property. Okay, all right. That goes to multiplicative identity property, right? So example of that is simply going to be a times 1 equal to 1 times a equal to what, a. Now you take a, so this means multiplication. Now for multiplicative identity property, where you have a to be any number, I only use 2 because it's easier to express. So but a can be any number, so a can be any number in the word. So just for easy demonstration, so this is a times 1. Obviously we know any number times 1 will always be that very number, right? So let's say a is 2, this becomes 2 times 1 equals to 1 times 2, which gives you 2. So that is how it is expressed. Pardon me, this is a. Pardon my handwriting. Alright, the last on my list here that I will explain here, we have multiplicative inverse too. The same way we have the additive inverse property, we have the distributive property. So for this video not to be too long, I'm going to stop here and I will continue in the next video in the part B of this. In the part B, I'm just going to show you the, okay, I hear some say that I should continue. Alright, I'll just continue, but I'm going to rub this off so I can continue with the last 2 on my list here. So okay, take this off. I want to leave this because this is very important. So the last second to last is called the multiplicative identity property. Example of this is the multiplicative inverse. Please pardon me, properties. Yeah, the inverse of this quick example that will give you a dot 1 over a. Please, this dot simply means multiplication, please. Okay, in advanced classes is you use dot, so but you can use multiplication though. So equals to what, 1 over a dot a, which will give you what, 1. Okay, that's what it is. Okay, only on the condition where a is not equal to 0, because if a equal to 0, it can never be 1. That's another topic for another day. I'm not going to discuss that right now. So what this means that let's say for instance a equals 2, so this becomes 2 times 1 over 2 equals to 1 over a over 2 times 2. So you can know this cancel out, this cancel out, this cancel out, this cancel out, that give you what? 1. So that is why for multiplicative inverse property, this expression is what? True. Alright, the last on my list will be distributive properties. Distributive properties is so sweet. Let me just put this here. Distributive property. Alright, for distributive property, it's very simple. Just say a b plus c equals to what? A b plus ac. So what distributive property does, it opens up the bracket. Yeah, it opens up the bracket. So just easy. Let's take for an example. Let's say a is 2, b is 3, and c is 4. So to show that this is true, because the left hand side must equal to the right hand side, as you can see here. A plus b, a into bracket a plus b equal to what? AB plus AC. So for you to prove that this property is true, you need to solve them separately. You solve the left hand side and you solve the right hand side. So you solve the left hand side and right hand separately. So we are going to do that here. So let me quickly take this off, so I can quickly take this immediately. Okay, let me just put this here. Okay, so for the distributive property, so let's look at. So we are going to take the left hand side. So let's just take the left hand side, right? So we have a into bracket b plus c, right? So and I said our a, what is our a? I said our a is 2, b is 3, and c is 4. So whatever we get them, we must get them clear. So solving the left hand side, right? Please ensure you take your notes properly and do not write scattered as I've written on the board, please. So a is 2, right? Open the bracket. B is 3. This is b. Open the bracket. C is 4. Right? So if you open this there's a multiplicative sign here. So there are several ways you can deal with this. Either you open the bracket through, or you take it from inward after. So I'm going to open the bracket to this become 2 times 3, 6, plus 2 times 4, 8. So if you add this up, it should give you 14. Right? So if you put this here from that expression, 14. So let's deal with what we have here. So let's deal with the right. So right hand side. Right hand side, we have a b plus b c plus ac. You know, I said this simply means a times b plus a times c, right? So our a is what? 2. Yeah, as you can see, our b is what? 3. Our a is 2, and our b is what? Our c is 4. So 2 times 3, 6. 2 times 4, 8. If you add this, I will give you 12. So this is 8 times 14 rather. So this is the proof that distributive properties is true for the left hand side and the right hand side. So thank you so much for staying tuned to this end. My name is Mo Friday. In my next tutorial video, I will look forward to explaining another simple concept that I believe will help you guys out there. So stay tuned. If you are new to my YouTube channel, please kindly click on the subscribe button below so you get notified whenever I upload the next video. I'm gonna drop that very soon. I'm gonna put it in the comment below. So do check in the description, below, so you get the next topic that I'm gonna be taking. Thank you so much, and see my next video. Bye bye for now.